Welcome to Book Screen Talk, and let's solve today's problem. Find all duplicates in an array. Given an integer array nums of length n, where all the integers of nums are in the range 1, n, and each integer appear once or twice. So just once or twice, not repeated more than that. Return an array of all integers that appear twice. The algorithm should run in O of n time and use only constant extra space. So if you've been doing the March everyday coding challenge, the yesterday's problem was a bit similar to this one. You just had to return the one number which was repeating, but in this case we have to return all those numbers which are repeating. So if you think about it, the easiest way to do this is just use an extra space, maybe a hash map, and just keep a track of all the numbers. And let me pull up that solution real quick. Following yesterday's solution, you just declare a dictionary. Then for each number that you encounter in nums, if it is not equal to none, that means we've assigned a value before, so we've visited that number before, so that means it's repeated. So you just append it to output, right? And you return output. And if it is not in nums, that means you're encountering it for the first time. You just assign the value for that key, that is the number, equals to 1. And we know that the number appears only twice, so we are not worried about incrementing the count of the number. We just assign it 1. And if we encounter that it is not none, that is if the value for that key is 1, that means we have encountered it before, so we just append it to the result and then we just return the result, correct? But the problem with this is, as I didn't realize yesterday, is that it is still taking up O of n space and not a constant space. Why O of n space is because the space which you occupy will depend upon the size of the nums, right? The bigger the nums, the bigger your space complexity. So we are required to solve this problem in O of n time. Of course, this takes one pass through the nums, so of course this is O of n time, but it's not O of n space, right? It's not O of 1 space, it is O of n space. So in order for us to do or code up a solution in O of 1 space, we have to understand a different technique. Let me prepare the board for that. So if we look at this example, right, just to reiterate, we know that n is always in 1, n range, right? Since the length of nums is 4 here, range of the numbers is always going to be between 1 and 4, correct? So that is why I've taken 1 and 4 as an example here. Seeing how this algorithm or iteration works, it is better when we look at examples which have 2 duplicate values. It's just better to understand what's happening, right? So as we iterate through the array, we are going to mark the number as visited, but we are going to mark the index of by what the number is representing. So what I mean by this is, suppose we are iterating through this array and we encounter the number 1, right? So what do? We take this number 1 and we go to the n minus 1th position, that is the index, and we mark that node as seen. How do we mark that node as seen? We just convert it to a negative number, right? And since we know that there are only max repeated numbers are only twice, that is, a number is repeated only twice and not more than that. So that means if we encounter a negative number while we are iterating through the array, we visited that node before, or we visited that number before, correct? So that is the intuition behind this. Let us just walk through an example to understand what really is going on. So at the 0th position, we have the number 1. So what we will do is we will take n minus 1. What is n minus 1 is 0. We will replace it with minus 1. So now this 1 becomes minus 1, right? This is the answer. Then we go to the second number. Then again we have 1, right? But what is the 1 minus 0? So we again look at the n minus 1th position, which is 0 again. And we see that it is minus 1. What does that indicate? It indicates that we have already encountered this number before, right? So if we have encountered this number, what do? If we have an output array, we just append it to our output array, correct? Right, and we move forward, right? But since we have already visited this node, what we need to do is we need to change this back to a positive integer. We just alternate between, it's like an on and off switch. So if you encounter the number, you turn the switch on, and if you encounter the number again, you turn the switch off. So when you turn the switch off on this number, you just get +1, right? Yeah. So the array now is 1144, correct? And we were at this index. Now when we come to this index, second index, we get the number 4. So we look at which index? 4 minus 1th index. So that's the third index. So where is the third index? It's here, correct? So we'll see that this is a positive integer. Okay, so we'll make it negative, correct? Then we move forward and we come to the third index now. And what is the number? 4. 4 minus 1 is 3. What is the third index? It's minus 4. That means we have encountered this number before. So we'll append it to our result array, make it a positive one, that is turn off the switch, correct? So that's the intuition behind this. There's a very elegant tutor for you to understand how programs work and what the internal working of the solution looks like. I usually code in Python, so I use the Python tutor. There are other languages supported in that tool, but and I'm not sure, but there may be other avenues where you could visualize your code too. But just to show you how it works and what it looks like, I'm going to switch to that tool now. Right, so this is a tool. If you see, I've coded up the solution, but let's not look at the code right now. Let's just look at the visual aspect of this code. Let me just get rid of all the ads. So firstly, we are declaring nums, right? So it just declares a list of nums. Then we have an empty list for result. Then we just iterate the list. And we take the absolute value of the result as our number, right? Because we are not concerned with whether it is negative or positive when we append it to the... so we need to have a positive number in order for us to append it to our result, right? So we just keep a backup of that number. But when we actually check whether a number in nums is negative or positive, we will use our normal, like not an absolute value. Okay. So first it is checking n1, that means the first index, right? This is so it is checking the first index of the n. First it will check whether the 0th position is positive or not, right? So it is positive, that means we assign a negative value to it and then move forward, correct? Then for the next iteration, again, we have 1. So 0th position is negative. That means if it is negative, we will append it to our result array. And again, we will turn off the switch. So we just make it positive, correct? Then again, for the next number is 4. So 4 minus 1 is 3. So third index is what? 4 again. So we negate it because we haven't encountered it before. So we negate it. And then again, at the third index, we have minus 4. So since minus 4 is less than 0, that means we have, found this number before. So we append it to our result array and we turn off the switch. That is, we make it positive, and that's the end of the loop. And that's what we return, correct? This tool does not support functions as of now. So it's kind of annoying. You have to edit your code a bit to actually understand how the algorithm is working. But I found it very helpful during my early days when I was learning how to code and learning algorithms. So if someone who's starting out, this is a good visual representation, and it really helps with understanding difficult concepts, especially linked lists and trees, which you have to keep drawing with your hand to understand. Right. Let's jump back to the code. So as you saw before, the code is very straightforward. We maintain a output array and we iterate through the list. We take the absolute value of the number because at the end of the program or at the end of the loop, the number which we want to append might be on or off, that is, might be positive or negative. So we need the absolute value to be appended to our list. That's why we take the absolute value. We know for a fact that a number is repeated only twice. So if the number is negative, that means we have encountered it before. So if it is negative, we'll append it to the result array, right? Else, we just negate the value. So if it is negative, it will become positive, and if it is positive, it will become negative. Once the loop ends, we just return the output. It's a very straightforward solution, and if you don't know of this solution, it is very difficult to come up with this, especially for O of 1. Well, you do think of it in those regards that you will have to, modify the array in place somehow, but you never think of, it's difficult to think of the intuition that you change the index of, or by what this number represents, right? And this only works, by the way, because the array is in range 1, n. If there were no limits to this, it won't be possible to do the solution in O of 1 space. I don't think so, right? Because if this is any number, the list of index can go out of range, correct? So this is the trick here, and this is an important constraint which needs to be kept in mind. Yeah. So this is the solution, and that's it for today. Subscribe for more.